It's really it's an honor to be here. Happy Earth Day to everybody. It's a special honor to be here as my maiden voyage as a faculty affiliate at Sea Solutions, and it's a special honor to do that at a school that bears the name of Jonathan Fielding. Jonathan, if you're on the webinar, a salute to you for your leadership and your vision for all these years. I'd also like to acknowledge before going on that I'm speaking from Seattle, the traditional unceded land of the Coast Salish peoples, and in particular the Duwamish tribe. I honor with gratitude the land itself from which I speak and the tribes. What I'd like to do in today's talk is just three things. It's a simple agenda. I want to introduce the paradigm of planetary health. I want to work a few examples with you, and then I want to close on a hopeful note because there is a certain risk when you talk about planetary health that it sounds a little grim. So let's begin with the paradigm, with the big picture. And although most of us are health professionals, I want to ask you to channel your inner historian and your inner ecologist as I go through and introduce 7 key concepts: the Great Acceleration, Deep Time, the Anthropocene, Planetary Boundaries, the Donut, Ecosystem Services, and the Poly Crisis. All of these together form the framework and the background for planetary health. So let's begin here. The origins of planetary health are probably no more evident than here deep in a Scottish coal mine in the mid-19th century. Coal had been recognized for at least 1,000 years by then and used on a large scale for a century or more. But by the time of this image, coal was making energy available on an unprecedented scale and revolutionizing industry, the so-called Industrial Revolution. I especially like this picture because the British gentleman sitting at the bottom of the coal mine saw fit to wear his wig down into the coal mine and to light his pipe, which is not a great idea in a place that may have methane gas in the air, but it's a nice example of the reckless insouciance that nicely foreshadows the energy economy of the next century and a half. Where planetary health might begin here, this is the Drake Well in northwestern Pennsylvania. 1859 is when it was drilled, almost exactly the same time when the previous picture was done. This was the first commercial oil well in the US and possibly in the world. Liquid fuel, in addition to coal, represented another form of plentiful energy, and before long it had revolutionized transportation and given rise to a booming synthetic organic chemical industry. And I can't leave the subject of oil without acknowledging that all of you sitting in Southern California are sitting right at one of the epicenters of oil in this country. The upper picture is one that I took 10,000 years ago. That's the La Brea tar pits, which at the time were one of the finest places to eat in all of the LA region. And the lower picture is a picture taken in the early 20th century at a time when California was producing no less than 1/4 of the world's oil supply. Well, with all that oil and coal, world energy consumption began to skyrocket. A lag of a couple of decades, as you see here, but the fossil fuels, coal and oil, and then a little bit later, natural gas, complete with its anodyne and slightly deceptive name, formed a revolution in the availability of energy. Now, keep the shape of this graph in mind, because I'm going to show you several graphs with the same shape, and that shape will become a recurrent theme. All of that energy enabled other ramp ups of the human enterprise. This is a picture of world population over the last 12,000 years, slowly increasing over the last millennium, but really skyrocketing once there was enough energy around to support a larger population. This is a picture of world GDP over the last 2 millennia. And you can see that economic activity as measured by the GDP also skyrocketed in line with that great availability of energy. In fact, almost any index you can think of the human enterprise, from water use to transportation, to fertilizer consumption, production of plastics, papers, the number of McDonald's outlets, all of those things have ramped up enormously in the last century or two, and especially in the years since the Second World War, a time called the Great Acceleration. Now, the Great Acceleration has been a great time to be alive as a human being. This is probably the healthiest, most thriving time in human history, albeit inequitably distributed across the world. This is a picture of illiteracy dropping dramatically. This is a picture of poverty dropping dramatically, even as the global population has continued to increase. This is a picture of child survival increasing. This is a picture of life expectancy increasing. So the Great Acceleration has been a great moment in human history, but it's come at a cost, and much of that cost is borne by the planet. So a word on the context and scale of the planet. If we were to scale the planet to the size of a soccer ball, then the entire biosphere, from the deepest ocean trench to the very top of the troposphere, would be about as thick in scale as this piece of saran wrap. It's an enormously thin sounds like a contradiction. It's an extremely thin layer in which all of life on Earth is supported. And a word about that life on Earth. This is a picture of all of life on Earth, a cartoon representation using tons of carbon as the metric, about 550 gigatons of carbon. The entire animal kingdom, which includes us, is a small percentage of 1% of all of life on Earth. And if we blow up that animal kingdom, we can see that humans represent a small percentage of 1% of the entire animal kingdom. Insects are most of it, fish are a big part. Wild mammals are a small fraction of the human biomass, and the livestock that we maintain to feed ourselves actually is bigger than our biomass. Those unusual conditions were not the state of nature, and they're a reflection on human alterations of the planet. Now that speaks to the mass of humanity. Let's think about time, deep time. The Earth has been here for 4 or 5 billion years. Life appeared about 2 billion years ago, vertebrates less than 500 million years ago, mammals a couple of 100 million years ago. Our species, Homo sapiens, is about 200,000 years old. We emerged from being hunter-gatherers to growing crops, writing things down, and living in towns just 10 or 12,000 years ago. This is all nicely expressed by John McPhee, who wrote, "Consider the Earth's history as the old measure of the English yard, the distance from the king's nose to the tip of his outstretched hand. One stroke of a nail file on his middle finger erases human history." Now, given that we are a very small part by mass and a very small part temporally of the history of this planet, you might think that we couldn't do much to change the essence of the planet and its functions, but you'd be surprised. This is a picture of planetary changes over the last couple of centuries. You can see that human activity has changed the chemistry of the atmosphere, changed the surface temperature of the planet, changed the pH of the oceans, changed the land cover on the planet on a large scale, extirpated many, many species. The planet is changing dramatically as the result of human activity, that scale up of the Great Acceleration that I showed you. Changing so dramatically that the geologists have postulated that we've entered a new geological epoch, shifting from the Holocene, the 12,000 or so year long epoch in which civilization as we know it emerged, to the Anthropocene, geological epoch characterized by human control of many Earth systems. And that in turn has given rise to the notion of planetary boundaries. This is an iconic picture. What it shows is that across about 9 parameters, climate change, biodiversity, land use, fresh water use, biogeochemical flows of phosphorus and nitrogen, and others, there is a boundary beyond which we shouldn't transgress. The green zone here represents staying within the boundary. That's a safe zone. The red areas here represent transgressing the boundaries, as we've done already for biodiversity and for biogeochemical flows. Transgressing those boundaries has the significance that it risks triggering irreversible and potentially catastrophic changes in Earth systems. Now, as health professionals, you may be looking at this diagram and saying, well, where's the people? Where are the human needs that exist within the context of these planetary forces? So let's redraw the picture like this. It's the exact same picture: climate change, ozone layer depletion, pollution, and so on, with the notion of an ecological ceiling here and overshoot being the risk zone. Then let's put people in the center. with all of our needs, food, water, energy, social equity, political voice, and so on. And let's postulate that this social foundation is a floor below which we shouldn't go. So the sweet spot is this area in the middle, the safe and just operating space for humanity, as described by the Oxford economist Kate Raworth in her book, Donut Economics. It's a really good model for thinking about the two sets of goals that are companions to each other. Now, a companion way of thinking about the way we live within the context of Earth's systems is to think about ecosystem services. Those of you who have studied ecosystem services will recognize this. The notion here is that the planet, when intact and when functioning with integrity, supports us in many ways. Supporting services such as forming soil, provisioning services such as giving us food and water, regulating services, think of a mangrove forest protecting us from flooding, cultural services such as spiritual, educational, and recreational activities. We can then take this concept of ecosystem services and map them to the components of human health and well-being. It becomes a complicated picture, thanks to the Millennium Ecosystem Assessment. But what you can see here is that health as the outcome that draws us together, as well as security, basic material for good life, good social relations, all can be mapped to these ecosystem services, health in very prominent ways. So again, the notion here, the core belief of planetary health is that we can't be healthy as a species without having a healthy planet with which we live in harmony. And moreover, that the many changes to the planet that we have wrought are disruptive enough that they increasingly account for a large share of human suffering and premature death. Now, I've mentioned all of the changes that are shown here, so much so that the planet we inhabit now is not the same planet our grandparents inhabited. We have altered the planet in fundamental ways as shown here. But it's even more complicated than that, because these changes occur in the context of social and demographic and economic changes that also have to be part of our thinking. So we live on a planet where the population continues to grow, where much of the population is aging, and where globalization binds us together more tightly than ever, as indicated by this picture showing pre-COVID daily flights around the world in a globalized world. We live in a planet where poverty and income inequality, related but distinct concepts, are regrettably common, and where racism and discrimination limit the opportunities for large numbers of people. We live in a world where disinformation flows rapidly, more than ever thanks to social media, where populism is common and where authoritarian governments thrive on that populism. And we live in a world where biomedical conditions include both pandemic illness, as we know too well, the spread of non-communicable diseases, which still kill many more people than pandemic illness, and the growth of loneliness and social isolation. So all of these together form the context in which we need to think about ways to advance and protect human health. Now, these things don't operate in isolation. They interact with each other. That's no more clearly depicted than in this iconic picture of a COVID sign in the context of California wildfire last year, probably driven in part by climate change. So that the best way to depict what we should call a polycrisis is a picture something like this. Each of these changes interacting with each of the others, exemplifying the first law of ecology, that everything is connected to everything. And this is the polycrisis which health sciences needs to confront. Now, there's one more element I want to mention before moving on to some examples, and that is an element of timing. I'm going to show you a few slides that demonstrate a timing challenge, and that is that most, if not all, of these changes are rapidly accelerating. This is a picture of biodiversity loss, and what I want you to see is the rapid acceleration of the loss of vertebrate species, which seems very steep until you realize that the extinction rate of insect populations, as shown here, is 7 or 8 times higher than that of vertebrates. Biodiversity loss rapidly accelerating. This is a picture of Antarctic sea ice loss, rapidly accelerating. This is a picture of glacier loss, rapidly accelerating. This is a picture of weather-related catastrophes globally, rapidly increasing. With all of these accelerating changes, we increasingly approach tipping points, such as the slowdown of the Atlantic circulation, or such as the loss of the Greenland ice sheet, any of which, if we arrive at it, can lead to permanent, catastrophic, irreversible changes in Earth systems. So this is an alarming uh, temporal trend. One more word on timing. I'm going to show you this relatively complicated picture. This is a picture of various modeled pathways to limit global warming to 1.5 degrees. Each colored line represents a different pathway based on different socioeconomic assumptions and different assumptions about the responsiveness of Earth systems to greenhouse gas emissions. Any of these pathways would get us to 1.5 degrees and keep us from going way beyond that. What they all have in common is that they all assume dramatic greenhouse gas reduction emissions starting now, arriving at a 50% reduction 10 years from now and getting to net zero by 2050, as you see here. But emissions continue to rise. We're not seeing the rapid turnaround that we need to see. So with all of the complex polycrisis elements that I mentioned, and with the fact that these are accelerating rapidly, we in the health professions know the word to describe this situation, and here it is. And it's in this context that the field of planetary health is emerging. It began with a 2014 manifesto, to use strong language, in the Lancet. It was followed a year later by the publication of this report from the Lancet Rockefeller Commission on Planetary Health. The Planetary Health Alliance is a professional organization that appeared the year after that. Academic units around the world have been appearing in the years since then. And then, as Lynn was kind enough to mention, a couple of textbooks are now out, which are kind of reflections of the emergence of planetary health as a field. It's defined in relatively verbose terms in the Rockefeller Foundation Lancet Commission report, but the key thing is that it blends human systems with natural systems. It's defined as the health of human civilization and the state of the natural systems on which it depends. The core proposition is that you can't think well about one without thinking about the other. Let's turn to some examples, and I'm going to turn to quotidian arenas, the things we do every day that'll help us understand the applicability of planetary health thinking, the energy we use, the stuff we make, and the food we eat. So let's begin with energy. Now, you might think climate change is the obvious example of a planetary health challenge, and in fact, it is clearly a very big one. Climate change, as you all well know, introduces a whole portfolio of health threats through various pathways as shown here. But I don't want to talk about these today, partly because we could take all of our time to talk about climate change, partly because I think most of you know this well already, and partly because even if the climate weren't changing, we would still need the field of planetary health. And I'll try to make that case through the rest of the talk. But the one thing I do want to say about climate change is this. This is a picture of household income levels across the US from low income to high income. And the y-axis shows household carbon footprints. What I want you to see here is that those of us who are relatively fortunate have much larger carbon footprints than those of our country fellows who are less fortunate. And if you deconstruct those carbon footprints, they relate to everything we do, the food we eat, the housing we inhabit, the clothing we wear, the transportation we use, the services we use. Wealthy people are responsible for much more carbon emissions than less wealthy people. And that's true not only in the US, but globally. This is a picture of the world's population arrayed on this y-axis from the poorest 50% here at the bottom to the richest 10%. And you can see that the richest 10% account for almost half of lifestyle consumption emissions, and the poorest 50% for only about 10%. Same pattern that we see in the US, that carbon emissions and depredations of planetary systems really have been the doing of the wealthiest and most fortunate among us. But the victims are the poorest among us. This is a picture you may have seen carbon emissions by country over 50 years with a big bloviated US and Europe and a little vestigial Africa and South Asia, but climate-related deaths showing the reverse pattern, a big bloviated Africa and South Asia and little barely visible North America and Europe. So this is a key lesson of planetary health. Equity considerations run through the entire field and need to be at the center of the research we do and the solutions we generate. The energy example I do want to spend a little time on is dams. Now, what do we think about dams? Well, this is a picture of various ways to make electricity. Here's coal on the left, natural gas here, with greenhouse gas emissions on the y-axis, indicating that the fossil fuels are very high in the greenhouse gas emissions consequences of making electricity. And way over there on the right is hydroelectric, which is one of the lowest carbon footprint ways to make electricity. So dams that generate electricity are a mighty good thing in many ways. Here in the Pacific Northwest, where I live, our river system, the Columbia River system, is pretty much built out with dams. All of these red and yellow dots are different dams. And that's the reason that the electricity that I'm using to power the computer on which I'm speaking with you is 2/3 or more renewable, because we have a generous supply of hydroelectric energy here. This is turning out to be a worldwide trend. There are almost 3 million dams in the world, mostly for flood control and irrigation, but about 3,500 are hydroelectric. And interestingly, about the same number again is under construction. We are in, as this paper calls it, a global boom in hydropower dam construction, with this bar here on the right showing the dams yet to be built. Also seen in these pictures, where the purple dams are operating, but here across South Asia and here across Latin America, the red are planned and the yellow are in construction. So dam construction is rising fast. Now, as good as dam generated hydroelectric energy is, it has some adverse health consequences, exemplified nowhere better than here at the Three Gorges Dam, completed back over a decade ago now, where over 1 million people were displaced with well-documented impacts on mental health, on social cohesiveness, and on human well-being. In fact, dams represent a perfect example of trade-offs that Planetary Health is well positioned to think about. The benefits of clean electricity, a dependable water supply, irrigation, flood control, but the risks and downsides, indirect in terms of altering ecological conditions as shown here, and direct risks of infectious disease, population displacement, and when dams collapse, of catastrophe. So this represents a planetary health concept of complex trade-offs, often not bad versus good, but good versus good. These are the trade-offs that need to be thought through very carefully so that optimal decisions can be made. Dams represent another planetary health concept as well. That's shown here. Each of these benefits is liable to vary with climate change. So for example, if we have lower snowpack, different timing of snowpack melt, more severe rainfall events, as we are having with climate change, then each of those functionalities of dams and each of the ways in which dams supply electrical power may be changed. We shouldn't be doing any planning at all now without thinking 5, 10, 50 decades into the future, because we know that we're living in such a rapidly changing world. And that's a part of planetary health. We need to be thinking about future trends all the time. Next, let me move as another example to the stuff we use. And here I want to talk about plastics. Now, plastics, as you know, are polymers of various simple molecules such as ethylene and propylene and styrene. Wherever you are now, sitting in your bedroom, in your kitchen, on your porch, if you look around, you will see some plastics because they are ubiquitous in our lives. We take them to be so normal that it's easy to forget that plastics only began to be a part of the world after the Second World War, part of the Great Acceleration. We now produce over 320 million metric tons per year globally, or about 40 kilograms for each man, woman, and child on Earth. That means that on average, each human being now alive will account for over 2,800 kilograms of plastic production over his or her lifespan, 30 or 40 times our body weight. It's used in the ways shown here: packaging, consumer items, construction products, and others. Not only is plastic production extraordinarily high in volume, but it's increasing, projected to more than double over coming decades as the world becomes more prosperous and the demand rises in growing parts of the world. Now, plastics are persistent. If the workers who built the Great Wall of China or Machu Picchu or the Taj Mahal 5 or 6 centuries ago had sipped water from plastic bottles during their breaks from work, those plastic bottles would likely still exist. What happens to discarded plastic is consequential. By one estimate, for every human being now alive, there is somewhere in the world about 1 metric ton of plastic, over half of which is waste, no longer in use. And that waste stream is growing. Where does the plastic go? Well, some of it's in landfills, some of it's in waterways, a common and heartbreaking sight in many of the world's major cities. Plastic generally floats, so it travels with currents and accumulates in eddies, forming patches that can be as large and imposing as islands. From streams, rivers, and harbors, it winds its way to oceans, an estimated 5 to 13 million metric tons each year. Driven by wind and currents, the plastic seems to go everywhere, making this a global problem. It's been found in the deepest ocean trenches, in Arctic ice, and Mongolian mountain lakes, on remote island shores. The world's ocean systems tend to concentrate waste in the 5 great ocean gyres that are shown in this picture. Interestingly, the highest concentration of plastic debris ever measured on a beach was on remote Henderson Island on the western edge of the South Pacific Gyre, 5,000 kilometers from the nearest significant human habitation. Now, plastic waste exists across a spectrum of sizes, from macroplastics like the 6-pack holder that entrapped and literally shaped the life of this poor turtle, all the way down to microplastics and nanoplastics, some of which are made that way, such as the clothing microfibers in the clothing that we wear, some of which is a degradation product of larger pieces of plastic. A lot of that plastic enters ecosystems. It's taken up, for example, by seabirds, an estimated 90% of which now have plastic in their bodies. This albatross is an example. But perhaps even more interesting is what happens to the micro and nanoplastics as they enter food webs. These pictures show the uptake of polystyrene beads, which are the fluorescing objects in green, by various zooplankton. And you can imagine what happens as this travels through food webs. The nanoplastics and microplastics are taken up by very small critters, which are eaten by bigger critters, which are eaten by bigger critters, all the way to the top predators, which include the orca shown here and the human beings shown here. Plastic is in the food web that we eat. Now, we're beginning to have evidence of the magnitude of this problem. In one recent study shown here, fish and shellfish from markets in Indonesia and California were assessed for plastic debris. And there it was, in a quarter of the individual fish that were sampled and well over half the species that were sampled. When we eat fish, we're eating plastic. And we're actually getting more and more evidence now about the presence of microplastics in many other food groups, as you see here: sea salt, honey, beer, bottled water, and so on. According to one recent analysis, which pooled data from 26 studies, Americans ingest between 39,000 and 52,000 microplastic particles annually. It's about 1,000 a week, depending on age and sex. That number roughly doubles when you consider inhalation, about which more in just a second, and it roughly doubles again for people who habitually drink bottled water. So with all that plastic coming in, it's no surprise you can guess where this goes. And we have now one little study, only 8 volunteers from Europe and Asia, of stool, and plastics were found in every stool sample that was tested. Now, why does this matter from a health point of view, besides that it's yucky? Well, plastic isn't just plastic. About, on average, 7% of plastic consists of additives such as plasticizers, fillers, and flame retardants, many of which are persistent, organic, and toxic chemicals. Not only that, plastics efficiently adsorb synthetic organic chemicals to their surfaces, including many such as PCBs. In fact, that widespread distribution of organic pollutants or persistent organic pollutants, POPs, is a defining feature of the Anthropocene. Ingestion isn't the only pathway through which we absorb microplastics. That consumption study I mentioned a moment ago also estimated that the mass of inhaled microplastics can equal or exceed ingested microplastics. This is a diagram from a just published paper that quantified plastic content, including chemical components in ambient particulate matter in the Pearl River Delta in China, substantial burden, with the largest part of it being phthalates. Now, plastics, together with their fellow travelers, POPs, travel. The concept of biogeochemical cycles that traditionally referred to natural flows such as carbon, water, phosphorus, nitrogen might also be appropriate for plastics and POPs. POPs are fat soluble, they bioaccumulate, they bioconcentrate, and as they move up the food web and move around the world, they are increasingly found in large organisms, including in humans. One recent study of Inuit people in the Canadian Arctic found that those with the highest blood levels of PCBs were 1.9 to 3.5 times more likely to have diabetes than those with the lowest PCB levels. So here is a planetary health lesson. Problems that originate in our consuming habits and that seem local actually go global and need to be considered as a new form of global health challenge. There's another planetary health lesson here, lest you become too glum at all of this bad news, and that is that there are solutions at hand. We did very well for many, many years without plastic, and it's possible to move off of or to minimize the use of plastic. This is a picture of the countries around the world that have banned, restricted, or taxed the use of plastic bags. And one notable thing is that most of the progress is happening in low to middle income countries, not in wealthy countries. That's a lesson. Here in the US, this is a picture of which states have banned or limited the use of plastic bags. 9 states have legislation banning plastic bags, but there's another lesson here. Twice as many states have state laws that ban the banning of plastic bags by localities that may wish to do that, driven by a lobbying group called the American Progressive Bag Alliance, which is a subsidiary of the Plastics Industry Association. So change is possible, although vested interests can powerfully oppose change. Next example, and the second to last, is food, and I want to talk about nuts. Now, for those of you with nutritional backgrounds, you probably think a lot about healthy foods, including the consumption of nuts. Eating nuts is generally considered to be good for human health. In fact, there's a large body of literature singing the praises of nuts, of cashews, of pecans, of walnuts as components of good health. Cardiovascular risk is lower, many health outcomes improve. And so epidemiologic studies typically show that this is a benefit and recommend that we eat more nuts. The kinds of questions that we hear about in the nutritional world are these. What are the components of nuts that are so good for us? How do we create healthier nuts? How do we get people to eat more nuts? And so on. But there's one question that doesn't get asked enough, possibly because of the siloing of our thinking. Where do nuts come from? Well, everybody knows the answer to that. They come from convenience stores. They come in little bags like this, and you simply buy them. But if you go back upstream from there, nuts come from orchards that can be very beautiful, like this almond orchard or this walnut orchard. Well, where are those orchards? As you can see here, the US is a major producer of nuts. We have the predominance of the world's share of almond production. China leads the world in walnut production, but the US is second. Let's talk about nut production in the US. Where does that happen? Well, all of you in California probably know the answer. California has 80% of the world market share of almonds. All these blue areas are the nut growing areas. Same thing, California dominates in the production of walnuts. So, as we recommend the consumption of nuts to more and more people for health purposes, that has implications for California agriculture, doesn't it? This is a picture of the water footprint of various foods. How much water does it take in liters to produce a kilogram of the food? You can see that cow meat is one of the highest in water demand, but second to that is nuts. Growing nuts requires a lot of water. Now, you know better than I that recent years have been a challenging time in water terms for California. And not only that, coming years are predicted to be a challenging time in water terms for California as well. More chaotic weather extremes, more severe droughts, less water from snowmelt. So when we make a recommendation nutritionally to eat more nuts, that has implications for a growing area in California where it's arguably very difficult to continue to produce and increase the production of nuts. So this is a planetary health principle as well. When we think about strategies to improve health, ground them in ecological thinking, ground them in mindfulness of ecosystem limits, and come up with the right answer only through that sort of composite thinking. Well, this has been pretty glum. I've described a lot of really worrisome trends in the world. I want to end on a high note by talking about an example of the Diama Dam. We'll come back to dams now. This is a dam on the Senegal River, not a major dam. It's only 18 meters high, but it helps to store water and support irrigation in surrounding communities in Senegal. 18 meters is high enough to keep the tide from pushing brackish water back up the river, creating above the dam an ideal freshwater habitat for snails. Now, snails, as you may recall, form part of the life cycle of the schistosoma trematode, or fluke, the cause of schistosomiasis. Sure enough, after the dam was built in 1986, snails proliferated along the river, and a fierce outbreak of schistosomiasis followed. But a win-win ecological solution emerged, and that was prawns. This is a brilliant series of papers that describes the stocking of the river with prawns, which are predators of the snails. One result was a dramatic reduction of schistosomiasis. Another result was an improvement in the health and well-being of people living along the river as they gained a dietary protein source and a cash crop. So the solutions that emerge from fusing biomedical, ecological, sociocultural, and economic thinking, this is what planetary health is all about, can be truly inspiring. I want to close with a comment that speaks to planetary change in environmental public health, speaks to data, to narratives, and to teaching. The planetary changes I described are grim. I recently spoke on climate change to a university class, and I asked them how many had confronted despair in considering the issue. Every hand in the room went up. No surprise, despair is an occupational hazard for anybody who considers contemporary planetary changes. We need to fight despair. Despair is immobilizing, it's painful, and it doesn't accomplish anything at a moment when we have to be about accomplishing a lot. We need to embrace hope ourselves and inspire hope in others. Fortunately, there's plenty of basis for hope, and that's what I'd like to close with. I'm going to go through quickly 8 reasons for hope that are listed here, and hopefully leave you feeling hopeful. First is Cobenefits. Now, here you see 4 key elements of the green economy depicted: clean energy, well-designed cities, healthy diets, and green chemistry. I'm going to juxtapose alongside those some of the major public health goals we've got. We would love to reduce heart disease, lung disease, and cancer, improve mental health, reduce the number of infectious diseases and injuries, and assure healthier child development. Well, here's the good news. We have very strong evidence that clean energy delivers all of the health benefits shown here through improved air quality and other pathways. We have very strong evidence that well-designed cities deliver all of the health benefits shown here. We have very strong evidence that healthy diets do much the same, and that green chemistry contributes as well. So the story of coping with planetary changes, decarbonizing the economy, living in harmony with the planet is not a story of deprivation and sacrifice. It's actually a story of better, healthier lives in many ways. Second reason for hope, technology is advancing. Battery technology, for example, which we need to facilitate the change from fossil energy to renewable energy, is improving dramatically. Even something as difficult as renewable aviation fuel is advancing rapidly. So we are seeing major technological breakthroughs. The economics are improving, and there's no better example of that than the fact that renewable energy costs have come down much faster than anybody predicted, such that renewable energy is now cheaper than fossil energy in most places. Policy is maturing with more and more countries making net zero commitments. Not as many as we'd like, not as fast as we'd like, but national commitment, national leadership from many countries that include some major emitters such as Japan and Germany is inspiring. At the subnational level, we're seeing cities competing with each other to be the first ones to go green. And even in very small towns, we're seeing dramatic improvements such that the relics of the fossil fuel economy, gas hookups, gas stations, and so on, are being banned by some localities, and electric vehicle readiness is a priority in some localities. Another reason for hope: activism is blossoming. This activism motivates young people and ultimately motivates policy change. Public opinion is shifting. This shows the proportion of Americans who are extremely sure or very sure that global warming is happening, and it has been steadily increasing even during the years of the Trump administration. Here's a remarkable artifact. On election night, exit polling of voters by Fox News showed that 70% of the Fox News respondents favored increased government spending on green and renewable energy. So public opinion, even in one of the most torn countries in the world about climate change, the US, is improving. Culture change is possible. These are posters left over from the Second World War that urge people to turn off the electricity, use less meat, don't buy stuff you don't need. And the public stepped up and did that, indicating that this kind of change is possible. Results are emerging. This is a picture of the growth of renewable energy in recent years, and it is dramatic and fast. In fact, last year, renewables pulled ahead of coal. This is a great piece of progress. In the private sector, the automobile industry is competing with itself now to be the first to go all electric. So many, many reasons for hope, and I hope to leave you on a hopeful note. Planetary health is the health of human civilization and the state of the natural systems on which it depends. It is people-centered, systems-based, upstream-facing, equity-committed, future-oriented, solutions-driven, hope-inspiring, and I hope that it is of interest, and I hope that you'll be engaged in this field as it expands in coming years. Thank you very much.
All right, thank you, Dr. Frumkin. That was an amazingly hopeful note to end on. Tons of fascinating information in there. I'm sure it's a lot to digest for a lot of people. So I just want to, remind everyone to use the Q&A function right now. We have some that have come in, but I'm going to go ahead and go into the asking questions at this time. I'd like to start with the asymptotic graphs that you showed in the beginning of your presentation, significant growth. Usually when we see charts like that among other species, they're usually followed by, collapse charts. And so, but humans are different than frogs, and they're different than bird species, due to our technology and adaptability. So, for example, the Green Revolution was one that was able to solve nutrition concerns of the 70s. But not without substantial environmental harm due to pesticides and fertilizer runoff. So, how different and resilient are we? What do you see going forward with all of these, converging crises?
Well, it's a great question, and if Thomas Malthus were here, he would have to eat crow right now, because he famously forecast the collapse of human populations in the face of food scarcity, only to be proven wrong by the Green Revolution. Like, technology really can offer important solutions. And the good news is that many of the technologies we need, such as harnessing the vast amount of incoming energy from the sun without burning further fossil fuels, that technology is available and ready to be deployed and is being deployed. So we may get ourselves out of some of this fix with technology. But equally important is the political, social, and cultural change that has to happen. And that part is a little bit less easy to feel confident about. It would be great if we were wired to think about long-term threats instead of immediate threats, if we were wired to think in terms of solidarity and mutual support instead of tribal affiliation and competition. It would be great if we were wired to sacrifice when we need to and take care of each other. But that's not necessarily the way people are wired. So we have to be about bringing about the cultural and political changes that are needed so that we can fully implement those technologies. I'm hopeful that we can do that. I think that the spirit of the question, James, was that there is plenty of basis for hope. And that was the message I tried to end with. And I think technology is a big part of the reason for that hope.
Great. Building on that, I'm personally fascinated by the concept of the Fermi paradox. Are we alone out there? What stops species from becoming, interplanetary, for example? So do you think we're headed towards a great filter for our species? Do you feel like, we can break through that as well?
Uh, and do you mean going interplanetary?
Yeah, I mean, like a great filter, what causes societies to collapse, something like that. I mean, it's a similar question.
Well, if the question's about will we go interplanetary, I have no opinion, but I
Okay,
accept to think that if and when that ever happens, it's not going to be nearly soon enough to be the solution to the problems we currently face.
right.
So
Okay,
it's an interesting speculation, but I think we need to be about solving current problems now.
excellent. And how do you suggest we effectively draw popular attention to generate action towards planetary health, given the competing interests and priorities that are out there?
Well, that is a huge question, and I can't pretend to have all the answers, but I one piece of the answer that I would like to emphasize is that health is a highly motivating frame for many people. So that we now have some evidence that if you frame the climate crisis as an environmental problem, or an economic problem, or a security problem, or a health problem, there are large sections of the population, not everybody, but large sections, including some who are quite skeptical, who are persuaded by the health frame that this is something that we need to take seriously. I also think that what the Biden administration has done has been masterful. That is presenting climate solutions as part and parcel of jobs and equity, because those bread and butter concerns understandably dominate the daily concerns of many, many people. And if we can, uh, through some sort of a Green New Deal approach, link equity and economic security and an environmental solution set, that's going to be the most politically feasible way to make major progress, I think.
Okay, great. We got one other question coming in. What websites or other resources would you recommend for checking, the latest findings on news or about the state of the environment? Is there any particular sources that you go to?
Well, the ones that I read every day are from Climate Central and Environmental Health News, which is an NGO in Virginia, publishes several daily email announcements. One's called Above the Fold, and one, I forget the name of the climate one, but if you go to Environmental Health News, it might be called Climate Daily. Those are very helpful. The Planetary Health Alliance has a really great website that in turn takes you to a number of other resources. And then one of my favorites, because of the beauty of the prose as well as the information that it includes, is Bill McKibben's weekly column in the New Yorker on climate change. He's an absolutely gifted writer, and he has his finger on the pulse of climate policy better than anybody I know.
Great. And so in my role as sustainability manager, I'm often talking to nurses and physicians and the next generation of clinicians as students. Is there any particular role that healthcare providers can assume to help mitigate climate change and their health risk? What can providers and clinicians specifically be doing?
Well, I think that each of us who's a health professional actually is not just one person, but many people. We are private citizens, we are clinicians, we are researchers, we are institutional leaders, some of us, we are community leaders and trusted voices. And in each of those roles that we fill, there are things we can do. So in our personal lives, we can make changes in what we eat, how we travel, and how we consume, and so on. And we can exemplify and model those changes for friends and family and community members. In our role as clinicians, if we're comfortable doing this, we can use the clinical setting as a way of educating patients. And I think that's a delicate, I don't want to be naive about that, but one wants to be non-judgmental and accepting and supportive in a doctor-patient or nurse-patient relationship. But it's a very trusting relationship. And if you're able to recommend, for example, that a patient maybe drive a little less and walk and bike more as a health benefit, or eat a little bit less meat and more plants as a health benefit, and point out at the same time that this is good because it helps to maintain the planet for all of us, that's a wonderful opportunity. We can speak out as public citizens, as public presences with trusted voices. Survey data around the world, including in the US, show that doctors and nurses are two of the most trusted professions. So taking a public stand, supporting the kinds of ordinances that I've referred to a couple of times, supporting policies that help to incentivize the reduction of carbon emissions. Boy, the health professional voice is extremely valuable there. So in each of the many roles that we have, there are things we can do. I'm just so encouraged that the younger generation of health science students that you referred to, James, is taking this on in a full committed way. And that's one of the great sources of hope for me.
Yeah, I agree. I absolutely love going and talking to the next generation because it's something they're asking about. It's something they want integrated into curriculum where it may not be. And as you know, there's so much in the medical school curriculum. We just need to find ways to insert all of the population health, climate change, and sustainability education there to, make sure that they're ready before they enter into the clinical space in our hospitals.
Right.
So I know we're coming up on time, but we got one more quick question, and it is, how does population management fit into planetary health? Should public health be taking that on?
Population management, meaning I assume reducing population growth.
I think that's what they're asking here. Yep.
Right. I'd actually fuss with the term population management because that implies a heavy-handed top-down approach. We clearly, a large and growing population is a part of the problem. So is the per capita consumption of goods and services with the resulting carbon footprint, because the total environmental impact is, roughly speaking, the product of the number of people around and the per capita carbon footprint. So to put the population question in perspective, one American on average has the carbon footprint of 30 or 40 Malawians. And so we should be a little humble about focusing on population growth in a prescriptive way for other people who have much lower impact on the planet than we do. That said, it certainly is a good thing to reduce the human population. And for my money, there are two reliable, acceptable ways to do that. Teach girls and empower women. Educate girls and empower women. And the reduction in population growth then invariably follows. So it's a nice example of how social commitments, in this case to the rights of women, the education of girls and the rights of women, the empowerment of women, social goals have to be considered part and parcel with environmental goals, because we can't achieve the environmental goals without also achieving the social goals. It's the right thing to do, and it's the practical thing to do.
Great. Well, that's an excellent note to end it on. So thank you so much. I'm going to turn it over to Lynn. I believe she has some final thoughts.
Yeah, and actually, instead of giving the final thoughts myself, I would love to introduce Dr. Jonathan Fielding, who I am so incredibly fortunate to work with. He is the founder and the co-director at C Solutions and an absolute giant in this field. So, Dr. Fielding, take it away.
Jonathan, nice to see you.
Well, Howie, nice to see you. What a bravura, just incredible commentary. And it's so broad and so far-reaching that anybody who watches this should watch it several times. It's that good. I think the educational issue is really an important one. And I think when we do surveys of the American population, it's still surprising how few people really understand some of the basic principles that you have been talking about. So I would like to say one of the opportunities we have is to embed that kind of educational information in primary education, in secondary education. You shouldn't graduate from high school without being able to at least give a paragraph from what we know. Because if we wait till people are adults and they already have strong views that have been conditioned by a number of factors, including the lobby groups and of the industries that are concerned, we're not going to get where we need to get to. So I think the other thing, in terms of a positive, then we have Gina McCarthy, who's been a warrior in this as the key advisor to Biden. That really speaks well for at least the effort that we're putting forward. and our international involvement and our commission's effort to change people's views. But I'm sorry, the last thing I would say is that people don't understand that it's not simply a question of reducing our carbon footprint. It's a question of basically trying to get the carbon footprint really close to zero net. And that's one of the very important lessons of Bill Gates' book, which I think is beautifully done. I recommend it. How to avoid a catastrophe, climate catastrophe. And I think hard for people to understand. So do you have any final comments about that? And again, thank you so much. It's wonderful to see your face. And by the way, it's not so bad to hear you either.
Well, thank you very much. Were you asking for a final comment?
I was.
1 minute before the hour. I too think Bill Gates' book is terrific. If I have any quibble with it, it's the same quibble that Bill McKibben has. And that is that it's a little heavy on the technological solutions and a little light on the political, social, cultural changes that we need. When, as we talked about earlier, I think we need both. And Bill Gates fully admits that. He says, I'm a tech guy. That's what the book's about.
I'm a nerd. He says I'm a nerd.
Yeah.
Thanks again, Howie.
Well,
Wonderful.
thank you for having me.
Wonderful talk.
And thank
Thanks,
you all
Glenn.
attendees. I appreciate your spending your lunch hour with us. Thanks very much.
Well, to wrap it up, since we're at the hour, thank you everybody so much for joining us. Thank you, Dr. Fielding and Dr. Frumkin, for your words. And we really look forward to further conversations around planetary health and human health. Thanks again, and happy Earth Day, everybody.
Thank you.